So here we will discuss about FPGA architectures, the main key component and the design. FPGA offers the reconfigurable architectures where the CPU offers the sequentially or the control that manages input output. FPGA allows the parallel executions, whereas the CPU and other they are not the parallel, making them ideal for the high-speed application, artificial intelligence, and the networking, defense, space, all this. Main key component is the CLB, switching matrices, IOs, LUTs, slices, and these things. CLB have a two slices. One CLB have a two slices. One slice have the flip-flops and LUT that will hold the main logic. If you want to design any just like as a D flip-flops, full adder, LUTs, it will handle by the flip-flops and LUT. It will hold by the CLB. One CLB that will interconnect with each other using the interconnected wire. It will be switched between the using the switching matrix. So it will interconnect the resource programmable the routing wires, switching for the flexible path between them. Input output that's the LV CMOS, LVDS. It will handled by the 3.3 volt, 2.5 for 1.8 for 1.2 volt. It will work on this all the voltages. Some other part is the embedded resources that have the VRAM, DSP, AIML, neutral networks, FFTs, the clock management part, the hard IP, PCI, Ethernet, DDR. All this comes under the embedded resources. This is the basic, the component of the CLVs. Whatever you are designing in your VHDL and Verilog language, it will hold by the CLV. It will work here. It will execute one CLV to another. It will provide the output to the IOs. So you can check on the real hardware from here. Now, the SoC FPGA. SoC is a system on chip. Here's an example of the Cyclone. FPGA, Cyclone FPGA is an Intel architecture based. That's have a two portion. There's FPGA portions and HPC is a hard processor systems. That's the software part you can say. There's a flash controller, the MPU subsystem that's based on the Cortex A9. On-chip memory, the PLLs, interface peripherals, all handled by the HPS. FPGA part and HPS, it will be interconnect to each other using the exit protocols. FPGA that's have the logic. There's a custom made and the IPs you can use and you will use the VHDL Verilog and the system Verilog language for the FPGA fabrics. So it will have LUTs, RAM, multipliers, and routing, all this. Now, FPGA was the CPU. What is the basic use of the FPGA for the AI/ML interface, 5G, radar, DSP, networking, space, defense, all these things because it's work in a parallel. So the speed is very high as compared to the CPU. That's work for OS, general computing, the server systems. Now we will go for the basic difference between CPU, GPU, FPGA, and microcontroller. So the main topic is the architecture. That's the parallel is the clock speed, the performance, programming language, which language we use, latency, flexibility, power consumption, costing. What is best use of that? First of all, we will discuss about the architectures. FPGA is a reconfigurable architecture. So it will be more than 1 to 2,000, okay, more than 1,000. So you can reconfigure using the LUT, DSP slices, DRAM or architectures of the microcontroller is a single low power core. CPU have a very high, this is a few, but it's a very powerful, let's say 2 to 32. GPU has a very high cores. Now parallelism. In the parallel applications, speed is very high because the pipelining techniques that's used by the FPGA is extremely high with the custom pipelining to the true parallel. GPU, that's the thousand of the threading system that's used. CPU also use the threading system. And a microcontroller also can use the threading system, but here is a single task. So we can use the threading system to make it the parallel thing in a controller. The clock speed. Speed of the clock is very high in a CPU, that is 2 to 5 gigahertz. GPU, that's a 1 to 2 gigahertz. FPGA most probably work between 100 to 600 megahertz, but in the parallel. So speed is very high. Now the controller is the 400 megahertz. Now the performance. For the general purpose, we use CPU. Massive, the math application, the parallel application for AI ML, the training system, we use the GPU. The FPGA for the custom real-time accelerator, the simple control task is handled by the microcontroller. Programming language, VHDL Verilog, system Verilog language. For the FPGA, the CUDA, OpenCL, PyTorch, TensorFlow, used for the GPU. CPU, we use the C, C++, Python, Java language, and the C language we use for the microcontrollers. Now we'll go further. The latency, you can see here the medium, high, very high, and the very low. Flexibility, there's a fully reconfigurable is the best for any of the application for the high-speed application. This is a fixed architecture. All this CPU, GPU, and controller that's have a fixed architecture, whereas the FPGA is a fully reconfigurable. It's now the power consumption. So very low power consumption by the microcontroller. Optimized design. And this depend on the FPGA have the medium because it's depend on the optimizer design. So whatever you are designing the language, so it will make some of the logic in the get level design. So it will take some of the delay depending on the multiplex, DP blocks, and it will depend on your logics and IP core, whatever you are use. The costing, the very high costing for the GPU and the FPGA, depending on the zinc, vertex, kintex, all is a family for the Xilinx and the Cyclones and other for the Intel FPGA, the microchip FPGA, depending on the FPGAs and according to your applications, costing is different. Best uses for the general purpose, you can use the CPU and for the artificial intelligence, machine learning, the training application, the graphics simulations, we use the GPU. And for the radar DSP networking and the space defense, AI interfacing, we use the FPGA. IoT application and some of the embedded application, we use the controllers. What is the basic use of the FPGAs? As I told you, that's for AI data centers, acceleration card, there's enterprise, networking, automotive advanced driver assistance system. Now is the automotive industry is going for the FPGA. It's as per is the pipeline techniques, so its speed is very high, so that's why automotive industry going for the FPG. For the data center in a stock market right now, the most probably companies they are going to use the SLSM card for the DSP high speed the calculations. So that's why FPGA is most probably used. What kind of tools we use? So depend on the FPGAs. For the Xilinx FPGA, use the ISC Vivado and the YT, whereas the Intel FPGA uses the Quarters, microchip uses the FPGA Libero. Lattice that's use the Diamond. So here is some other information about the FPGA architectures, the difference between CPU, GPU, FPGA, other controllers. And next, we will discuss about the what kind of the FPGA, the differences. It will based on the RAM based, the flash based, and so the applications based. The just like the Xilinx, so many have just like as uh, this is a flash based FPGA. We'll discuss it next. Thank you.